Hey everyone, happy snow day. We are obviously not having the factoring quiz today. We'll just have that the next time I see you in class. However, we are going to learn the next part of chapter 4, which is still based on factoring, so it might kind of help you practice that a little bit more too. But today what we're working on is determining whether or not a binomial is a factor of a polynomial. Remember, a binomial is something with two terms like x plus 7 or something like 5x minus 2. That's two terms. And a polynomial is anything with multiple terms. So it might be a quadratic, like an x squared plus 3x minus 4, or something like that. A polynomial just has many terms. Now you have to understand division and remainders in order to understand this lesson, and just like prime factorization. So let's do a simple example first. Think back to earlier in this chapter when we did 50 divided by 4. When we did 50 divided by 4, think of what we got as our answer. And does that tell us, is 4 a factor of 50? Why or why not? Take a second to think of your answer. Pause the video if you need to. Hopefully you're thinking that 4 is not a factor of 50 because when you divide, 50 divided by 4 has a remainder of 2. So we know that if it has a remainder of 2, that means it is not a factor. That's going to clue us in on our lesson for today. A binomial is only going to be a factor of a polynomial if the remainder is 0 when you divide the polynomial by the binomial. So like if we did 50 divided by 5, that would have a remainder of 0, so we know 5 is a factor of 50. This idea is called the remainder theorem. This whole thing that says a binomial is only a factor of a polynomial if when you divide it, the remainder is 0. Also, a little extra piece on the remainder theorem tells us that if you know one factor, like for example, if you know 6 is a factor of 12, you can find another factor of that number by dividing. So if you did 12 divided by 6, you get 2. That tells us that 2 is also a factor of 12. Whatever the quotient is also a factor of the original number. All right, so let's apply this to our polynomials now. It says, for example 3, use the factor theorem. Determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. If it is, factor the polynomial completely. So what we just said is that if we divide the polynomial by the binomial, we'll get a remainder of 0 if it is a factor. So what we're going to do is we're going to take this polynomial, divide it by the binomial. If the remainder is 0, we know that it's a factor. Since this binomial, x minus 5, is linear, meaning it's x to the first power, and it has a 1 in the front as the coefficient, we can use synthetic division instead of long division. You can always use long division if you'd like, but synthetic division usually is faster. So remember how to set it up is you put the opposite of the divisor, that constant, in the box. So instead of -5, we're going to put +5 in the box. You write out the coefficients of the polynomial. Make sure every power is represented. I see that it's a degree 3, so I know it goes degree 3, 2, 1, 0. So every power is represented here, and I write out those coefficients. The first number drops down as just what it is. Then you start following the pattern, multiply, add, until you get to the end. You multiply by the number in the box. So 1 times 5 makes 5. Then you add, straight down, multiply, add, multiply, add. So this is giving me a remainder of 0. Remember, the last number is the remainder. Since this has a remainder of 0, that tells me that this is indeed a factor of the polynomial. Now I need to write out the quotient, because I said the quotient is another factor of the polynomial. So we'll write this out. Remember, we start at 1 power lower. Since you did x cubed divided by x to the first, we know that's x squared. It always starts 1 power lower. So these are our coefficients. It's 1x squared minus 2x minus 3. You go down a power each time, and the last number is the remainder. We need to go ahead and write this out. Since the remainder is 0, x minus 5 is a factor of that polynomial. That was part of the question, so we need to make sure we write that as part of our answer. Now, the other part of the question said if it is a factor, you need to factor the polynomial completely. So once you have found out the quotient, you need to factor that more using our factoring techniques we were working on previously in chapter 4. So this one is a quadratic, and it has 3 terms. Anytime you have 3 terms, you're going to use the AC method. So you'll take a times c. In this case, it's 1 times negative 3, so you get negative 3. And you write down your b value. In this case, it's negative 2. Remember, you have to come up with a number that multiplies up to AC and adds up to b. So think, what can multiply up to negative 3 and add up to negative 2? Those two numbers are negative 3 and positive 1. With the AC method, you can split up the middle term. We could make it negative 3x and positive 1x instead of negative 2x. However, when the a value is 1, you can skip straight to the factors. When the a value is 1, we know that the two numbers we come up with are the two numbers in our factors. So x squared minus 2x minus 3 factors down into x minus 3 times x plus 1. So now you need to write out the entire factored polynomial. So we'll write it as the first polynomial that we were given, x cubed minus 7x squared plus 7x plus 15 is equal to x minus 5, which was the first factor we found, multiplied by our other two factors here, x minus 3 times x plus 1. Those two factors came from our quotient. When we did the division, we factored the quotient down more into those two factors. So you're going to start with the polynomial that they gave you. Divide it by the binomial that they gave you. If the remainder is equal to 0, you have to keep factoring your answer down and then write out the entire factored form. Also keep in mind, if it's a degree 3 polynomial, you need to be able to see x times x times x. That's how you're going to get x cubed, is by multiplying 3 x's together. Alright, pause the video and try the practice problem below. Here's the final answer for that one. And now we're going to move on to the next example, which is using the factor theorem to help us solve an equation. This says x to the 4th plus 9x cubed plus 23x squared plus 3x minus 36 is a polynomial with 4 real zeros. That tells me that it's going to have 4 x-intercepts. Given that negative 4 and negative 3 are 2 zeros, find the remaining 2 zeros by factoring. Sketch a graph of the polynomial. Before we get into this problem, I wanted to go off on the side and give you an extra example of an easier question. So let's say I told you that 462 has 4 factors. 2 of the factors are 2 and 3. Find the other 2 factors. If you were trying to answer this question, you would take the 462 and divide out the first factor given. So 462 divided by 2, you get 231. Now, this is the most common mistake. That's why I wanted to show you guys with a number rather than a polynomial. People think that they should go back to the original 462 and divide it by 3 now. However, you want to keep going with this quotient that you just got. So take that 231, divide that quotient by the other factor given, so that you're making it like a factor tree. So you take the 231 and divide it by 3 now. When you do that, you get 77. You're going to keep factoring out the quotient. So now you have 77. That's a lot easier to factor down. You know that that factors down into 7 times 11. Similarly, when you're working with a polynomial, by the time you're down to here, it's going to be a lot easier to factor. It most likely will be a quadratic from there. So it'll be probably using the AC method or something easier that will look more familiar to you with factoring. Okay, once you have all your factors, you have your first 2 factors, the 2 and the 3, and then you have your 2 factors that you just found. You're going to write out your prime factorization. So you start out with the number that you're given, 462. You say it's equal to 2 times 3. Those were the 2 factors that they gave you. And then you multiply that by the 2 other factors that you found in the final step. Now let's take that idea and apply it to this problem that we just read. So first, you have to remember the part from chapter 3 that says if negative 4 is a 0, then that means x plus 4 is a factor. Or if negative 3 is a 0, x plus 3 is a factor. Because remember, if you solve x plus 4 equals 0, you have to subtract 4 on both sides. That's how you get x equals negative 4. So keep in mind that the factor and the root are opposites. Now that you have the factors, you know 2 of the factors already are x plus 4 and x plus 3. You can divide them out. So I went ahead and I divided out the x plus 4. Remember, I can use synthetic division for that. When I divide it, I get a remainder of 0, and I knew that it was going to have to be 0 because they already told me in the question that x plus 4 was a factor. So now I'm going to take my quotient, my 1, 5, 3, and 9. I know that represents something with 1x cubed, da-da-da-da-da. I don't really care about writing out the quotient because now I'm going to take that quotient and divide out the other factor that they gave me. So I'm going to take that 1, 5, 3, and negative 9 and move over here to step 2. I'm rewriting my 1, 5, 3, and negative 9. And this time, I'm going to divide out my x plus 3. So I put negative 3 in the box. I do my synthetic division. And whatever quotient I get, now I'm down to x squared. Because I started with x to the 4th. I divided it once. That got me down to x cubed. And now I divided it again. That got me down to x squared. So now I'm on x squared plus 2x minus 3. Remember, these numbers tell me the coefficients. And again, I get a remainder of 0, which I knew was going to happen because I knew x plus 3 was a factor. With that quotient that you get, that x squared plus 2x minus 3, you have to see if you can factor it out anymore. It's 3 terms, so you're going to use the AC method and find out that it does factor more. It can factor down into x plus 3 times x minus 1. Finally, you're going to write your whole prime factorization out. You take your polynomial and say it's equal to the first factor they gave you times the second factor that they gave you, and it's multiplied by those two factors from the quotient. Now, in this case, since I see two matching factors, x plus 3 is in there twice, I'm going to write it as x plus 3 squared. Anytime you have a factor with a multiplicity of 2, we saw this in our homework the other day. That's where the graph is going to bounce off the x-axis. So when we go to graph this, here's what we're going to see. We have an x-intercept at -4. We have an x-intercept at -3. And we have an x-intercept at +1. Because if I were to solve x minus 1 equals 0, I know I would get +1. So I have x equals -4, x equals -3 twice, because it's a multiplicity of 2, and I have x equals to 1. Remember, since it's degree 4, I should have 4 zeros. So I put those intercepts on the graph. Now, with x to the power of 4, it's an even degree, which means my ends are going to go the same direction. It's also a positive coefficient. Positive leading coefficient. So I'm using my leading term test. I'm thinking of positive x squared. I know both ends are going to be going up. So I know this end has to go up, and I know this end has to go up. Now I need to figure out what does it do in between here. It has to go through the x-axis when it's only a multiplicity of 1. So I know this is going to go through the x-axis. However, in order to come back up to the x-intercept -3, I'm going to have to curve my graph. And here is not going to go, it's not going to go through the x-intercept of -3. Anytime you have a multiplicity of 2 or a double root, that's when you're going to see the graph turn and bounce off the x-axis like that. Now I can just connect it back to my next x-intercept at 1, and then I see it going up from there. So to make it clear, anytime it's only a multiplicity of 1 or it's a single root, it goes straight through the x-axis. If it's a double root, it bounces off the x-axis. So I see a single root, a double root, and a single root. That's my sketch for this polynomial. All right, guys. Next, we're going to be working on finding the zeros of a polynomial function. You're going to have it down pretty much with factoring and with using this remainder and factor theorem. So make sure you practice this. I'll post a homework assignment to help you practice it. And let me know if you have any questions. Have a great day off and enjoy the snow. Stay safe, guys. Bye.